So chapter 16 is about chemical equilibrium. And the quote for this chapter from Sir Hinselwood: "Nobody, I suppose, could devote many years to the study of chemical kinetics without being conscious of the fascination of time and change. This is something that goes outside science into poetry." So chapter 15 was about kinetics, how fast a reaction is occurring. How far the reaction goes, the extent of the reaction, is governed by thermodynamics. An equilibrium constant, K, is a measurable quantity that we use to quantify how far does the reaction go. Does it go all the way to the products? Does it kind of stop so you've got like half products and half reactants? Or does it just barely get started and only make a tiny bit of product? The equilibrium constant tells us about that. Now, in chapter 19, we're going to look at reasons for the magnitude of equilibrium constants, but that's not yet. So another little illustration from biochemistry. So red blood cells have a protein called hemoglobin. You know, it's a really big molecule with lots of atoms and stuff, and so we don't bother trying to write the formula or anything. We just abbreviate it HB. So hemoglobin reacts with oxygen. It binds with oxygen. This is a reversible reaction, so we have a double-headed arrow showing that it goes in both ways. The concentrations of the reactants and products are described by the equilibrium constant. Equilibrium systems are going to respond to changes in such a way that equilibrium is maintained. So what happens that keeps your oxygen getting to your brain is that in your lungs, there's a relatively high concentration of oxygen. And the blood comes through your lungs and is exposed to the oxygen, and the hemoglobin binds with the oxygen. Because we have a high oxygen concentration, that's going to cause this reaction to shift to the right. As this hemoglobin-oxygen complex goes through the bloodstream and gets into muscles and organs where the concentration of oxygen is low, the equilibrium shifts to the other direction, and the hemoglobin releases the oxygen. So it's really rather genius, right? Hemoglobin picks up oxygen if there's lots of oxygen around, and it goes around with it, and when it comes to a place where there's not very much oxygen, it says, oh, here, you need oxygen. And then it goes around through the bloodstream again to the lungs and picks up more. And just over and over and over again. Any questions? How does an unborn baby get oxygen? You ever think about that? Well, there's, the umbilical cord, right, and the placenta and stuff, but the mother's blood and the baby's blood are separate, right? Well, babies have a special kind of hemoglobin. It's called fetal hemoglobin. It has a larger equilibrium constant. So it's going to load oxygen at lower concentrations than mom's hemoglobin. So the fetus is going to get oxygen from the mother's blood, where these arteries and veins come close to each other. The fetal hemoglobin has a stronger attraction for the oxygen, and so it will take it from the mother's hemoglobin. And then it goes along in the baby's blood and does the same thing that hemoglobin does. When it gets to a lower concentration, it releases it. And the reason this works is that the equilibrium constant is different. If the equilibrium constant for both hemoglobins was the same, you wouldn't get this transfer, and the baby would not get enough oxygen. Anybody have any questions?